Yesterday we have comfortably completed about the array list. Still, we need to discuss few more things to understand about the linked list, right? These are the things that we have discussed. So, okay, the array list. What is why one has to go for collection? Anyone? What is the advantage that we have with these legacy arrays? What are the two disadvantages, major disadvantages? Can someone help me out
We,
with those answers?
we can store only one data type
Second one, size
and
is
it has only fixed size.
correct. Fixed size is always fixed, right? It is not dynamic in nature. So that is one of the we can consider that as one of the disadvantages, right? So to overcome that disadvantages, the concept of collections has been introduced. Okay, so we have discussed about the first concept, which is what array list. See, if you look at the hierarchy, we have seen these things, right? So in the top, okay, you have the collection interface, right? And followed by the list interface. Okay, under list, there are four classes, the four major classes. One of the classes are array list, and the second one is you have linked list. Okay, and apart from these two, you have two other classes, which is the vector and the stack. You have something like vector. Vector is also a class, and you have the class which is what, which is stack. 1 minute. Okay, you have the stack, right? So these four are the classes. Let us understand about this implementation. Okay, how the relationship is there between these classes and the interface. So when I say list and collection, they are the interfaces, right? And the array list, the vector, the linked list, they are what? They are the classes, right? So this array list is implementing the list interface, vector is implementing the list interface, linked list is implementing the list interface, stack is extending to vector class. So these are the classes. Let me highlight the classes. So these are the classes. Okay, and these are the interfaces. So yesterday we have discussed about what we have discussed. We have completed about array list. But there are some drawbacks that you have with the array list. What are the drawbacks that we have with the array list? The first drawback is, like in the arrays, we have drawbacks, right? Like in the array list, the drawback is it allocates contiguous memory allocation. Allocates, or else it expects. Array list expects contiguous memory allocation. Memory allocation. When I say contiguous, so when I say contiguous memory allocation, it is a continuous memory allocation. Okay. Second most disadvantages is when you insert or when you delete an element. When you insert or when you delete an element from the array list, okay, a lot of internal shifting is required. A shifting, lot of shifting it's happen. What does it really mean? To overcome these two disadvantages, one has to go for linked list. First of all, we have to understand that what disadvantages is that really means contiguous memory allocation, right? In anywhere, whenever you take any programming languages, all the manipulation will happen in one area. That area is called as what? The RAM area. So RAM area, what the RAM area is going to do? It is going to actually the storage will basically happen in which area? The RAM area. So RAM is going to have some memory. Let us say that for simplicity, I am taking that our RAM is very small. Our RAM is very small. Okay, a very smallest RAM we are going to use to understand this array list. It has only few memory blocks. In the real time, you will be having 4 GB of RAM. It is going to have close to you cannot even count that. There will be many number of memory blocks here, but for the simplicity, let us say that this is our a small RAM. So this is how the RAM is. So each and every block is representing a memory. This is representing one memory, right? The moment you start, when I say array list, let us say that when I start creating an object for the array list, array list, okay, let me say integer, let us say that al equal to new array. I have just created an object for the array list. So this line will try to, I mean, some memory gets allocated in our RAM area. Let me double the size of this RAM. 1 minute. Like this. Let us say that this is our RAM size. Okay. For the future purpose, I am copying it in. Right. So I am creating an object for the array list. So what happens? What is the default size of an array list? Anyone? 10, right? So the control, okay, the Java will try to occupy 10 memory blocks continuously. It will identify, is there any continuous memory blocks? So in the real time world, okay, when you consider the RAM memory, so the RAM memory, it does so many things internally, right? It consumes memory for the notepad, okay, it consumes memory for the operating system, right? The memory consumption is very much, it is not even rudimentary. It consumes memory for each and every task that you start opening in your operating system or in your system, right? So for some other tasks it may be consuming these memory blocks. For some other tasks it may be consuming these memory blocks. For some other tasks it may be consuming this memory block. For some other tasks, let us say that these memory blocks are occupied. Okay. In the meantime, if you start running your Java application, which on demand, which has to create a memory in the RAM, because this instruction by default it requires what? It is going to consume 10 spaces. This is the default size of the array list. Okay, the Java program will check for the contiguous memory allocation. Okay, it will check, is there any continuous 10 blocks sequentially. So 1 2 3 4 5 6 7 8 9 10. In our example, in our RAM size, we are able to find the continuous memory block. Okay, let us say that even there are some kind of disturbances here. Let us say that some other code is using these memory blocks. Okay, now is there a way for this particular code to consume 10 memory blocks continuously? Is there any continuous 10 memory block? No, right?
No, sir.
This is a disadvantage. See, you don't come across this situation in the real-time application, because in the real-time application, definitely the size of the RAM is more than the size of the RAM that we are imagining now. This is not even this is the negligible size. The real-time application, the RAM size is something like, could be like 4 GB or 8 GB. Definitely, you will find a way to find a way for the array list to give its continuous memory allocation. Okay, the default size is 10. In future, you might be having the size as 1000 or 10,000, let us say. Okay, searching this is a disadvantage, I am saying. Okay, the Java application will try to search for a memory block, okay, with the contiguous memory allocation. 10,000 blocks it has to search it sequentially. Then only the memory allocation will happen. There is a concept of the searching itself is consuming some time. Okay, if there is no contiguous memory block for 10,000 spaces, memory cannot be created. The code will not run. Do you think are you seeing that this is a disadvantage? Looking into the contiguous memory allocation or continuous memory allocation. Are you getting what I am trying to say? So to overcome this disadvantage, linked list has come into the picture. How linked list is going to overcome this advantage, that we'll understand. So this is one of the major disadvantages. What is the disadvantage that we have just discussed? Okay, in the array list, so there are some disadvantages. The first one is it expects the continuous memory allocation. So time consuming. For small memory areas, no issues. For a very big memory area, just to look for a memory, a continuous memory, which it can get it, but still it is considered as a disadvantage. Right? Now the next one, when you start insert or when you delete an element from an array list, a lot of shifting gets happen. Now look at this point. What does it really mean is, let us say that we have found the continuous memory allocation. Okay, let me redo this. Let us say that our default size is what, 10, right? So this is the 10 default size. So it is going to occupy one from here 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 10, right? Okay, let us say that you are adding some elements from the index 1, like 1, 2, 3, 4, 5, 6, 7. So we are just adding the values. These are not the index numbers, we are directly adding the values 7, 8, 9, and you have what you have. So far so good. Okay, so the default size is 10, so this memory has been occupied, contiguous memory has been occupied. Defaults for the default size 10. Now let me say our code, right? Let's do something here. Okay, so I'm adding list dot add. So I'm adding 10 values. I just want to add 10 values. Is there any error, that any mistake we are doing?
Opening and diamond braces, sir, after array list.
Okay, this is
New array list
okay.
job.
Okay, this is missing. Huh? Let me do one thing. Sometimes it happens. Integer al equal to new. Okay, we'll do one thing. Huh? Let me create new package. Sometimes this happens. Our project is. Let me create package form.org. Let me create class file new driver class. I am having the main method also, going to keep the main method also. And let us introduce array list here. Array list integer type. I want to add integer value, so I am keeping the generic type as integer. Al equal to new array list. Okay, al dot add. What I want to do, I want to add one, like from numbers from 1 to 10. Okay, let me really change this to 3, 4, 5, 6, 7, 8, 9, and okay, after adding all the values, okay, I just want to print if the values are successfully added or not. If I print this, you see that the you see everything in the console. So this is going to allocate, this line is going to allocate memory continuously for the 10 blocks, right? Now what I want to do is, after this line, I want to use a add method. There is one more add method. Okay, look at this add method, which is accepting two arguments. First argument is you can give any index here. First argument is you can pass index. If I pass the index 3 here, right, and if I pass something like on the third index, add the value 100. Focus here. This add method is accepting two arguments. This is an overloaded method. Okay, this add method is accepting one argument, which means value will be added directly at the last index, right? But this add method, you can specify on which index you want to add the value. You can specify the index number here. Okay, after this, after adding on a specific index, I want to run this. I want to see how the values are added. If you see 100 is added exactly on which index? Third index, right? Now, sir, what is the deal here? What is the deal here? Now the shifting is happening internally. So you want to add 100 on the third index, right? So you want to add, this is the 0th index, and this is the first index. You know what is indexing now. So this is the second index, and this is third index. On the third index, you are trying to add a value 100. What will happen to the existing value? What will happen to the existing value? This value will be shifted to the next index. Okay, if that is so, what will happen to 4? This 4 will be shifted to the next index. What will happen to 5? 5 will be shifted to the next index, right? Likewise, the shifting will happen. If you add one value, you are adding 100 here. Okay, the value that is already there needs to be shifted to the next index in the array list. That is a disadvantage. So how many shifting you require? Okay, 1, 2, 3, 4, 5, 6. Okay, you require 6 shiftings. Since it is a small array, okay, shifting is required. At least six shiftings you are requiring. 6 shiftings. When you say the size of the array, let us say in the worst case, let us say that the size of the array is something like 1000. In the worst case, if you want to add an element, okay, you want to use an element method add on the 0th index. What value you want to add on the 0th index? Let us say that you want to add 1 on the 0th index, right? So it requires how many shifting? 1000 shifting. For adding one element is okay. So to do this internally, the array has to do what? The array data structure has to do a lot of shiftings. Right? That's why the insertion operation in the array list is not an easy task. For us, it is an easy task. With just a click, you're able to see the output. But internally, lot of shifting is happening. Likewise, if you remove one element, for example, there is a method called remove method. Let us say that al dot remove. Okay, so you can just give the index. If you give index like 5, okay, the element on the 5th index will be removed. Okay, after removing it, I just want to print this. Okay, now you see, while adding 100 on the third index, okay, 100 is getting added. All these elements are getting shifted one by one, right? But while removing the element on the 5th index, what is the element on the 5th index? So the 0th index, 1 index, 2, 3, 4, 5. 5 has to be removed. After removing this 5, okay, the 6th has to fill this void space, 7 has to fill this void space, 8 has to, again shifting is required to remove one element and to add one element. So this is a kind of very costly operation when you consider the time complexity. For us, okay, you are just like hitting it and you are seeing it. But internally, since computer is so fast, these things are being done, in a fraction of seconds, not even a seconds, in nanoseconds. Okay, but as per the computer perspective, as per the computer context, this is a costly operation. So this is seen as a disadvantage in the array list. Are you getting what I'm trying to say? Have I given justification for this too?
Yes, sir.
Now when someone is asking you what is a disadvantage in the array list, we don't see any disadvantage. Why you are saying it's a disadvantage? Okay, someone is asking like that. These 2 points are required. Array expects continuous memory allocation. That is one disadvantage. Second disadvantage, when you do the insert or when you delete an element from an array list, a lot of shifting gets happen. So justification has to be given. Right now, I was asking in the WhatsApp, what is a data structure for the array list? Okay, the data structure for the array list is internally it uses dynamic array. When someone is asking you what data structure is being used by array list, okay, array list is using what? Dynamic array. What is a dynamic array? Okay, it if you want to string the array, you can string. If you want to resize the array, you can do it. I can say that it is shrinkable and it is growable in nature. When something is shrinkable and when something is growable in nature, I can combinedly say them into one word, which is called a dynamic. That's why array list is what? Internally array list is using a dynamic array. What is the data structure of an array list? Anyone? When I ask what is
Dynamic array.
It is a dynamic array. Internally it uses a dynamic array. Dynamic array is what? Data structure. Okay, now let me see in the Google. I think we can see. We'll have to see the difference in the Google. What they have given. Different array list versus linked list. We will take this. We will see this. What they have given. What it says? Okay, it uses what? The class uses a dynamic array to store elements with it. Okay, now if you see a linked list, the class uses a doubly linked list to store the element. Okay, what is this doubly linked list? We'll understand that now for the better picture. Okay, now let us go.
Pointers.
Correct. 2 pointers. Correct. It has a 2 pointers. Okay, how the doubly linked list can be compared with the array list. So how the memory utilization is happening better with the linked list, doubly linked list. How these disadvantages are overcome in linked list, we will understand that. Okay, now how to create a class for the linked list? Very simple. Okay, so just remove all this. Okay, you just use the linked list integer L equal to new linked list. So again, this linked list is a part of java.util package. It's part of java.util package. When you add the elements, let us say that L dot add. Okay, I want to add 100. I want to add. Let me add only 5 elements. 110. Okay, let me add 99 here. Let me add 88 here. Let me add 76 here. So by looking at the output, we can come to a conclusion whether the insertion order is preserved or not. You tell me if I just hit this. Okay, you see the output and tell me insertion order is preserved or not. First of all, are we getting the output in the same order we have added the values?
Yes, sir.
So
Yes,
insertion
yes.
we can conclude that insertion order is preserved. Okay, it applies. It is same for array list also. Let us also see whether this linked list is accepting null values or not. Let us see the output, whether it is accepting null values or not. So null values are accepted. Can I get a conclusion? Null values are accepted, right? So let us see whether it is accepting the heterogeneous elements or not. Heterogeneous means the elements of different values. Okay, I just want to pass something like a string. Okay, without generic type, it is accepting the heterogeneous. Can I get to the conclusion? Can I get yes from everyone? Heterogeneous values are accepted without the generic type. But with the generic type, you can have a kind of control that only if you want to store homogeneous value, you can have that control by using the generics. So say everything is same here. So you don't see any difference. When you add, you're able to add. When you, let us see. After adding this, I just want to add something like, okay, I want to pass the index number. Okay, on the second index, I want to add what? I want to add 2222. Run this piece of code. Okay, after adding, we will print out what to do. Before adding this is how it is. After adding, this is how it is. So don't you see that the output level, output in the console level is same for array list and linked list? Can I get yes from everyone? Output in the console level. Console level is same, no? That you don't see much difference. But internally, okay, so many things are happening internally. Let us understand the internal data structure. What is happening behind the scenes? So why they are calling us the data structure is doubly linked list? We'll get that with this example. Okay, let me share the screen once again. Let me share the screen once again. You able to see my screen?
Yes, sir.
Okay, okay. Our code is very simple. Now someone tell me, is there any default size concept in linked list? No such thing is there, okay? In array list, the default size is 10. In the linked list, there is no default size concept. Why there is no default size concept in the linked list? We will understand. In the group, I think Balaji has mentioned that default size is not there in the linked list. It is 100% right. Understand. So when you see that, okay, the moment you start the moment you start creating an object for the linked list, okay, so there is no concept of default size. But when you start adding, the moment you start adding the first element, focus here. You want to start adding the first element, a random size will be picked up. Any random size, whatever the JVM is coming across in the RAM area, it is going to pick up any random size. Let us say that it's picking up this random size. Okay, the value will be stored inside this random size. What is the value? 100. 100. This random size is going to have a memory. Let us say, for now, let us say that the memory is something like small a. This memory area is something like small a. Along with this random size, okay, it is going to consider two more entities along with the, okay, the value is getting added in a random size that is going to have an address. For now, let us say that it is a, right? Along with this, it is going to occupy the immediate next block and the immediate previous block. Okay, this block will be treated as the next. Okay, this block will be treated as the previous. Okay, so this is the actual memory allocation. Have you understood till now? First line, only the first line. Firstly, this value
Yes,
will
sir.
be added in the random area. First thing, okay. Second thing is it is going to have an address. For now, I am taking it as small a. Along with that, it is going to occupy the immediate next area and the immediate previous area. Why this is happening, I will let you know. Again, in the second line, what is the second line? What is the second line says? You are adding another element. Now this time you are adding 10 here. This 10 will be added in any random area, right? And again, it is going to have an address. For example, let us say that B, right? And the immediate next area and the immediate previous area will also be occupied. Second element is also added. Okay. Likewise, you see third element, right? Third element is what? 99, right? 99. Any it will pick up any random area. For example, let us say that 99 is going to have an address like C. Okay, and next, and you have what? Previous area. Okay. Okay. And at last, fourth one, 88, right? So let us occupy this area, random area 88. Let us say that the address is D. Okay, this is next. This is previous. Okay, this is another block. Okay, what is the last one? Last one is 76, right? So the 76 will be added. Let us say that it is getting added here, right? And let us name it as E. Okay, it is going to occupy the previous area and the next area, right? This is the previous one, and this is the next one, right? And this is the memory block. Okay, the memory block that is represented in the square boundary, the boundary in red color. Okay, this complete part is called as the node. This complete part is called as the node. Node is the combination of value, next reference, and the previous reference. So what happens is, so this is the first memory, right? Let me separate that. This is first memory, right? What is the element that you have added in the next, right? Next element is 10 you have added, right? So where is 10? So is the 10 next element, right? So what happens is, this is going to, the first element is going to store the value 100, and the same time is going to store the address of the next node, which is, next node is what you have added 10, right? The B address will be stored in the first node, right? So the second node will store the reference of the previous address. So this previous prev is going to store the address of the previous node, which is A. Likewise, the moment you start adding the elements by using the linked list reference variable, what is the third element? So this is the third element, right? Every element will have two references. Okay, it is going to store two references. The previous address of the previous element and address of the next element, right? And what is the fourth one? You may be thinking why this is happening behind the scenes. You will understand that shortly. Fourth one is this, right? What is the fifth one? One is this one. Okay. Now, are you wondering that, see, the first element, okay, you are adding the first element. So when you add the first element, there is no concept of storing the previous reference. Okay, there is no concept of storing the previous reference. So the first element will always have a node with the head value and the next address of the next node. First element will not have the address of the previous because there is no node created. This is the first node. Okay, that's why this place is called as the head. Likewise, the last element is not going to have the address of the next node. That is the last node. We do, sorry, this is previous and next, not next and previous. Okay, this is previous and next. My mistake. Yes, sir. 5 nodes. For the first element, there is no concept of previous node because there is no previous node for the first element. So we call it as yet. Likewise, for the last element, there is no concept of next node. So because this is the last element, so it is called as what? Tail. Okay? And each other nodes will have the two-way communication. It is going to store the address of the next node. It is also going to store the address of its previous node. Okay? Each and every node, okay, if you consider this thing as a whole, there is a link. One node is linked to another. What is the link that is established between two nodes? It is a bidirectional link. First, I can say that there is a concept of linked. There is a concept of linking. So linked, which is bidirectional in nature, that is why it is called as what? Internal data structure is doubly linked list. Now, have you understood why the name doubly linked list has come for linked list internal data structure? Hello?
Sir.
Yes,
Because it has each and every node has the memory. What kind of memory? The memory of the previous node and the memory of the next node. And the two nodes are connected in the bidirectional nature. Each and every node is connected except for first and the last. Every other node is connected with two directions. Double directions. That's what is called as doubly linked. Name wise, it is okay, sir. How this is overcoming the advantage of array list? See, in the array list, if you have a small memory, it is going to occupy any memory allocation, right? It is not expecting any continuous memory allocation. Randomly, it is taking one memory block and it is storing that value with the, and also it is occupying the next and the previous node. It is not like it is expecting a continuous memory allocation. So there is no, that disadvantage is addressed. Yes or no?
yes,
Array list disadvantage is an advantage here because array list is expecting continuous memory. Here it is not accepting continuous memory. The memory is chosen randomly. Along with that, it is just occupying the next node, immediate next node, immediate previous node to store the references of the next elements. The second thing is now go back and see the difference. You see, manipulating array list takes more time due to inter-implementation. When we remove an element internally, the array is traversed and see, I said no, lot of shifting will happen for the array list. Do you agree here? This is justified.
yes,
Now you see here, manipulating linked list take less time compared to array list because there is no concept of shifting bits here. The list is traversed and the reference link is changed. What does this really mean? This is the guys that we are talking about. This is the guys that the actual advantages. What does this really mean? So when I say what does it really mean, see, after this, right? You know how to print this, right? So you are just saying print the referential. Okay, internally what happens? The one iteration will be run internally. Okay, it will take all the values and it will print in the same order. That's why you see the order is same. The order is not. That's why you see that the insertion order is maintained. Then look, now focus on the next line. Next line, what you are saying? You are saying add two. I mean, you want to add. You want to add 2 on the second index. Focus here. Firstly, it will focus on the value, guys. Firstly, it will focus on the value. What is the value? 2222, right? It will choose a random area to store that value 2222. Okay, and it will also consume the immediate next memory and the immediate previous block and the immediate next block, right? After doing this, okay, so it is waiting here. It is waiting here. Where you want to add? You want to add on the second index. Whenever the array a doubly linked list has happened completely, right? An iteration will happen. The iteration will always starts from 0. So internally, the indexes will be assigned. Indexes will be like 0. You don't see this internally after creating the doubly linked list. The indexes will be happening like this 3 4. What you're saying on the second index, right? So where is the second index? This is the second index. Okay. What is address of this? See, on the second index, add 2222. On the second index, add 2222. Internally, what will happen? It will consume the address of the second index and it will put it here. See, right? And it will consume the address of the previous. I mean, previous index is what? Previous index is B. Address is B, right? It will put it here. Addresses will be replaced. As soon as addresses are replaced, this link will be broken. This link will be broken. Internally, a connection will be happening like this. Okay, this is going to be connected here. Okay, this is going to connect here. Okay, this is going to connect again here. The link will be broken. Okay, and you know, after breaking that link, it will get reconnected as per our instructions. As per our what? As per our instruction. So in this case, are you seeing any shifting is happening here? Shifting is not happening. Only the required memory block is added. The references are just getting changed. Are you able to witness what I am trying to say? Are you able to visualize?
Yes, sir.
Yes, sir.
Visualization is easy one, So you are not, for the array list, a lot of shifting is happening, guys. You see the array list, right? The previous example, you want to start removing one element. Right? If you want to add one element on the second index, so the value has to be moved to somewhere, right? That somewhere is the next index. Again, in the next index, there is one value. It has to move. Shifting is happening. It is a challenge here, right? A lot of shifting is happening here. This is a disadvantage that is kind of getting overcome here. No shifting is happening, just the link is getting disconnected and the rewiring is getting happened to its previous and the next location. This is an advantage of linked list. Apart from this two,
So those,
yeah,
sir, so the two blocks have same addresses, right?
no, that addresses will be changed. That's what I'm trying to say. This is going to have C, no, right? This C will be assigned here for this previous. Okay, the next, this is going to have the existing the same next address that is already pointing to. You just trace this, you'll understand. I have not traced this because you see I have to give E here, right? I did not give that. I have to previously it is holding the reference of the C address. Only the address references are
Only addresses will shift.
Only addresses are getting changed. Everything is remaining same.
Okay.
Changing the address is not a big deal, right? Only reference, when you just move the references, internally everything will. So it is a kind of only 2 or 3 changes, isn't it? Only you are breaking the link and connecting it, right? Apart from that, no shifting is happening. Other nodes are not affected. Other nodes are, the memory is same. Okay, the values are stored. Okay, they are not shifted to a different memory. They are in the same memory, right? Are you witness that? Are you able to witness that?
Yes, sir.
Memories are on the same place, but the addresses are getting shifted. That's it. Addresses are getting shifted. That's why it is seen as an added advantage in the linked list. No one is going to ask you this much in the interview. I'm giving this much because you understand this is only to understand what is a doubly linked list. You should not just be preparing like doubly. What is doubly linked list? That is what I have given. Right? See, it says insufficient memory utilization. Can we agree with this? Because it is expecting, it keeps on searching for continuous memory, right? Justification is given, no? But if you look at it, good memory utilization.
Yes, sir.
This is good memory because randomly it is choosing the memory, no matter what is it. You do not have to worry about this. It can be 1 or 2 or multi-dimensional. It can be single, double, or circling. These are the these are the very foundation level. For now, this is not required. Now the insertion operation is slow, realize, because shifting is happening. Yes or no?
Yes, sir.
But your insertion operation is fast because no shifting is happening. Now look at this. this class works better. Okay, when you have to go for array list, okay, it says this class works better when the application demands storage and accessing it. Very simple. With the array list, if you want to access, accessing is very easy in the array list. Why it is very easy? You just give the index number, I will give you the value. For example, on AL reference variable, you just pass the index, like get method is there, no? Get method will accept an index like 100. Okay. Within the constant time, it is going to get you the 100. Very easy accessing. If you pass index number, value will be retrieved. When you know the address, you know who is there inside, right? Very easy, right? When you want to find someone, you need to get their address first, right? Without address, if you try looking for a particular person, that is a kind of a difficult task, right? Hello, are you getting?
Yes, sir.
You pass the index. Index is a kind of address. I give you the value. Do you think that indexing is going to be duplicated? Is there any duplication for the index? No, right?
No.
Index is unique, right? With the unique index, value can be duplicated. But on that particular index, you are able to get the particular value, the correct value, right? So accessing, some will interviewer will ask you what is the advantage of array list. If you want to access data, if you want to store data in a quicker way, accessing and storing data in a quicker way. Not insert. I'm not talking about inserting and deleting. I'm talking about accessing and storing. Storing and accessing, they both go together actually. The stored value you access, right? The accessed value is already stored. They usually they go together. Okay, there is no. It is completely different from inserting and deleting. Accessing and the word storing, they go together because the stored value you access, the accessed value is something that is stored already. You're getting my point?
Yes, sir.
Right? So that's why the class works better when the application demands storing and accessing it. Okay. This is complete. The class works better when demands manipulation. What kind of manipulation? Manipulation on the stored data. Right. For example, if you want to do the a kind of the deletion operation or the insertion operation on the particular node, okay, so that works really well for the linked list. It says data access storage is very efficient and it stores elements upon indexes, because based upon indexes you are accessing the data. But here the data access is slow in the linked list. Why the data access is slow means, if you want to access a particular data, let me give this this example I will give you. Okay, let me say L dot get. Okay, if you want to get the value of get the value inside the second index. You want to get the value in the second index, it has to start iterating from the get node. Means, okay, that is for data structure. In the linked list, if you want to get the value in the second index, these index numbers are generated in the countable fashion. When I say countable fashion, internally there will be a counter. The moment it starts traversing from the head node, okay, this is the head node, first node, right? It will, it saves the count as 0. The moment it come across second nodes, the count will be incremented to 1. Third node, the count will be incremented to. Fourth node, the count will be incremented to 3. The count is nothing but the index. To get the actual count, it has to start iterating from the beginning. If you want to get the value on the fifth index, it keeps counting 0, 1, 2, 3, 4, 5. Some value 76. Slow, right? If you want to get the value on the 1000 index, if you have 1000 values, it has to start from the beginning. Slow, right? Hello?
Yes, sir.
Because the index numbers are not generated dynamically. They are a kind of what we call it as the only at the time of traversal, okay, the counting will start. That count number is equivalent to the index number, is equal to the index number. It has to start from the beginning to count all the nodes. That's why the theory says Data access and storage are not deluxe. What is it? Data access storage is efficient at the store upon indexes. Data access and storage is slow in the linked list because it has to start traverse from the head node. Okay. Deletion operation is not very efficient because shifting is happening. Deletion operation is very efficient. It is used to store only similar type of data. It is used to store any type of data. There is a contradiction. It is not like that. It is used to store only similar type of data. It is used to store any type of data. I'm not getting this. I'm not sure why both are going to store homogeneous as well as heterogeneous. Okay, so why can you say why less memory is used there? Why more memory is? What is the difference between these two? More memory is used here, but when
Linked list stores address.
correct, because in the linked list for every integer value, if you want to store one integer value, memory consumption will be happening for the every integer. Integer is consuming 4 bytes, right? But for the array, okay, array is a continuous memory allocation, right? Since it's a continuous memory allocation, array is going to be more efficient in the memory wise. Like memory consumption is going to be less. Example, for each and every integer that we are storing, 10 is an integer, 4 bytes, 4 bytes again 4 bytes, again 4 bytes. For every value, 4 bytes it is storing. But for array list, for all the array, a random memory will be chosen, which is comparatively small than the actual integer value. Since a block is consumed, right, it is not same as the one integer value. This thing we have seen that in the arrays concept. Hello?
Yes, sir.
Confused? Repeat my video, will get this. Confusion should be there. If you are listening it for the first time, definitely there will be a lot of confusion. But the moment you start repeating this, these things will become very easy. So the reason why I'm saying using this is just to understand how it has been defined in the theory. You should not get confused after saying this. Less memory issues, more. This is the reason. This is known as a dynamic memory allocation. This is also known both are dynamic memory allocation. On demand, it is going to allocate memory. Right now, there are some methods. Some methods in the linked list. We will understand that. Okay. Hundred, 10, and 9. Okay, this is okay. You see something like add first, right? When I say add first and when I pass something value, and after after applying this method on the linked list variable, the 100 value will be added in the 0th index. Okay, instead of 100, let me say, for the better differentiation, let me say 1111. Okay, previously, this is the actual list, right? And you are adding 1111 by using the add first method. Add first method is very like open. You know what it is doing because the method name is very clear. So first element, this value will be added in the 0th index or the first place. Likewise, you have one more method like add first. These are the specific methods to linked list. Add last. Okay, I want to add 1111 in the last. Right. So there are few more methods like L dot hold first. Okay, let me say 100. It is not accepting any argument. So what it is returning, you will understand. Hold first will return the first value in the linked list, which is 100. Right. Likewise, we have hold last method. Add first, add last, hold first, and hold last. Hold last means it is going to retrieve the last element. Right. Likewise, what else we have? Wait. is empty is common. Offer first, offer last. Okay. Okay, you have get first. Get first and fold first are almost same. Okay, see, it is also getting the first value, and it is also getting the last value. Last value. What else we have? Peak first. Peak first. So the peak first will be like, it is also returning the first value, guys. Peak first and peak last. It's also returning the last value. What else we have? Pop. Let's see what pop is doing. Pop is showing the, okay, don't get confused about these methods. It is utilizing some common methods. Okay, we need to differentiate the common methods and the specific methods in the next class. Okay, so when we discuss about the stack and vector, we will segregate the methods for array list. What are the methods are there in array list? What are the methods are there in the linked list? What are the methods are there in the stack class? What are the methods are there in the vector class? After the segregation, I will give you the assignment. Okay, I'm preparing the string manipulation assignment because I want to add some complicated content in there. By tomorrow evening, I will send you string manipulation assignment. Okay, so this collection will take two more, I think 3 more classes it will take, guys, because it is a topic that we need to understand in depth to understand the future topics, right? And if you still getting any confused, okay, I have a playlist. Okay,